Welcome back to another video. I'm reading pages 100 through 106, or the beginning of 106 of Tom M. Mitchell's Machine Learning. And it's a lot of, so they just, in most of this chapter, they just prove that you can derive the back propagation rule, and because you can derive it, you can find the stochastic gradient descent rule. So yeah. Yeah, so it goes through the proof of that, that you can do that. And then it goes to the training rule for hidden unit weights, proves that. And then it talks about convergence and local minima. So we know that in the backpropagation algorithm, it will converge to a local minima, but we don't know if that's the global minima. So there might be multiple minima that it can converge to, but we don't know if that's the best one or the global minima. They basically say in the book that it's not really an issue, because in most applications, I guess, I don't know what most is here, let's say 99%, that doesn't become an issue. But they also give you ways to kind of combat that issue if it is an issue. They even say the complex error surfaces represented by artificial neural networks is still poorly understood. So, but it gives you some ways to combat that. And then it talks about the representational power of feed-forward networks. So networks that do not go cyclically, they feed from, in this case, sigmoid units that feed into other sigmoid units that eventually converge to your target value. And it can represent, these kind of networks can represent Boolean functions, so yes or no, true or false, can represent continuous functions, so any continuous function, and arbitrary functions, so basically any function that has multiple layers. And yeah, so those are the three that it can converge to. Yeah, so that's pretty much the video. It helped me a bit to explain it. Hopefully it helped you. Let me know in the comments if there was some part that you wanted to understand that you didn't. Yeah, thanks.